and welcome to lesson 8H. I can use trigonometry to determine whether the dimensions of a given solid are feasible. All right, guys, this lesson is all about preparing you for our big end of year project. And so I want you guys just to keep in mind that this is all preparatory work. We're going to see a lot of images today. Some of them will not be possible. Some of them will be possible. And we're going to talk about why some of them are and some aren't. All right, this first image is a cone, and it's a cone with a radius of 2 inches, a height of 4 inches, and a slant height of 4 inches. And our goal is to determine whether or not these dimensions are possible. So anytime I'm looking at something like this, I'm looking for every right triangle I can find in the picture. And by the way, I see a right triangle right here. Yep. And I'm going to determine if that right triangle works. And so we're going to use Pythagorean theorem over and over and over again. So here, I'm going to see, does 2 square plus 4 square equal 4 square? Does that work? Well, 4 plus 16, in fact, does not equal 16. So this is not feasible, okay? Basically because, well, it's not feasible. Your slant height's too long, or too short. L is too short. Pythagorean theorem fails. Pythag fails. All right, let's take a look at our next one. This guy is a triangular prism, and they tell me that the base is an equilateral triangle with side lengths of 12 centimeters. The height, oh, what the devil just happened? Sorry, guys. The height is this right here. It's 6√3 centimeters, and the length of the solid is 16 centimeters. Now, again, the length of the solid really doesn't matter. That can be whatever it wants to be. I'm more concerned, does this work? If they tell me that this is an equilateral triangle with side length of 12, that means this length is 12, and this right here is half of it, so it's 6. So I'm going to test it with Pythagorean theorem. Does 6 squared plus 6√3 squared equal 12 squared? Well, let's check it out. That's 36 plus, this becomes 36 times 3. Does that equal 144? Well, that becomes 36 plus 108. And it does, in fact, equal 144. So the Pythagorean theorem works. But I also need to consider, if this is an equilateral triangle, then all of the angles in an equilateral triangle are 60 degrees. Which means that this little triangle right here that I'm going to draw is a 30, 60, 90 triangle. And it has lengths 12, 6, and 6√3. Well, I'm really happy about that because that actually does fit my n, 2n, in square root 3 pattern of special right triangles. So yes, this is feasible, and it's feasible because Pythagorean theorem holds and special right triangle laws hold. All right, let's take a look at this next guy. This is a hexagonal pyramid, and it has we learn here that it has a regular base, and that each side has a length of 5, and the height of this guy here is 12. All right, so with this, you're going to have to hold onto your seats. There are a lot of right triangles in this picture. First right triangle I see is right here. Right, I see a right triangle in red. I see another right triangle here with the radius, the apothem, and half the side length. I see, what else do we see? There's another one, but we're not going to have to check it, with the height, the radius, and the edge length, but we're not going to have to check him. Oh, and there's also a triangle on the face of this guy, going from here, 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 but again, as we don't have the edge link, I'm not going to have to worry about them. Basically, there are a lot of right triangles. But the ones I want to check in particular are the the first one in red. I think that's where we're going to start. If this side length is 5 in our hexagon, we need to find the radius and apothem to do anything with this. Now, from our n minus 2 times 180 over n, we learn that each of these angles is 120 degrees in a hexagon. So when we draw our right triangle here, where this is my apothem and this is my radius, that makes this angle right here 60 degrees. If this is a side length of 5, then this little piece right here is 2.5. Well, that's actually my n. The radius is 2n, and the apothem is n square root 3. So my radius is 5, and my apothem is whatever 2.5 times the square root of 3 happens to be. I'm not going to worry about it right now. We'll get there. So let's start off by, so that's the base triangle here. Let's now check and see if our red triangle works. So let's check this guy, the 12. This is the apothem, and this is the slant height. So looking at this guy, where we've got 12, 13, and this is the apothem, which we discovered was 2.5 times the square root of 3. I want to see if these hold. So does 12 squared plus 2.5 square root of 3 squared happen to equal 13 squared? Well, this becomes 144 plus 6.25 times 3. And I don't even have to finish working that to see that that does not equal 169. That is not going to happen. So this guy is not feasible. Because Pythagorean theorem does not hold. All right, let's look at some more examples. Okay, here we go. This is a square pyramid with a height of 24 feet, and our side lengths are each 10 feet. It looks like we've got a slant height of 26 feet. Now, before we get started, I want to make sure that I know what my apothem and radius are, because I'm going to need those for more calculations here, right? It's a pyramid, and so all these things matter. If this is 10 feet, this is my apothem, this is my radius. My apothem happens to be half of that. That'd be 5 and 5. My apothem is also 5. We love it when it's a square base, which means that my radius is going to be 5 square root of 2, because we can recognize that this guy ends up being a 45, 45, 90 right triangle with an n root 2 pattern. So the radius is 5 root 2. So now let's test some triangles. I'm going to start off by testing this triangle here. Let's start there, shall we? So this is the apothem, which we said was 5. So I got 5 squared plus, they tell me the height is 24. 24 squared, and I want to know, does that equal 26 squared? So we're going to work that out. Does 25 plus 576, that's 24 squared, does that equal 676? Well, that's a big fat no. It does not equal that. So when I look at this, this is not feasible, because Pythagorean theorem fails. Okay, let's take a look at yet another one. Okay, we've got a pentagonal pyramid, and we've got some really weird numbers. We are looking for within a reasonable margin of error, because of course, whenever we deal with funky numbers, we're after round, and there will be some error. So just keep that in mind. Before we get started, I'm going to go ahead, and they've actually given me my radius. That's my radius. The height is 28, so this guy here is 28. And then this 9 right here must be the apothem. Okay, that's my apothem right there. I'm going to start off by testing, which triangle? Let's test this triangle first. Why not, shall we? Well, that would be the apothem, which is 9.635 squared, plus the height, which is 28 squared. And I want to know, does that equal, within reason, the slant height, which is, goodness gracious, come back. Sorry, friends. Oh, no, we go this way, apparently. Goodness, how many slides did it skip? Sorry. Does that equal 30.427 squared? So we're going to plug those into our calculator. Well, when I plug it into the calculator, here I get that 9.635 squared plus 28 squared is 876.833, whereas this guy is 925.802. These do not match. Therefore, and they're not even within a reasonable amount of difference. So they are not equal. So this guy is not feasible. Love it when it's easy like that, right? Not feasible because Pythagorean theorem failed. By the way, guys, it's a lot harder to prove that something does work than something doesn't work because you have to look at every single triangle. So let's take a look at this guy. This is a triangular prism, and I have right here, really there's only one right triangle in this, and it's right here, okay? And if this whole length is 6, then this is 3, this guy's 8, he's 4. So let's make sure that he works. We've got this triangle, 3, 8, 4. Does 3 squared plus 4 squared equal 8 squared? 9 plus 16 definitely does not equal 64. So this guy is, these do not have feasible dimensions. They're not possible because Pythagorean theorem fails. Are we seeing a trend here? Okay. You know, we're going to skip these guys. Rectangular pyramids are miserable, awful things to prove. Okay, that brings us to the end of the notes. Go ahead, take a look at your extra work, and we will see you in class.